All right, guys, this is number 2 from the homework tonight. Going to get it started for you. You'll definitely have to graph it by yourself. You'll probably have to factor the quadratic by yourself, but I'm going to get you through factoring out that first term. So we have a cubic, which is what you will more than likely see in any case on the Common Core, Regents, whatever it is you're practicing with. We know that it's got 3 roots because it has this 3 as an exponent. So if we're going to factor this thing, we have to make sure we pull each of those 3 factors out to determine what the roots are. If I'm going to do long division, I need something to divide by. I need a divisor. So instead of just guessing randomly, what we talked about in class that we're going to do is we're going to test numbers that might be roots. And where we're going to get those from is this -6 and this 1. So we're going to set up our rational root test here by putting all of our factors of 6, that's going to be 1, 2, 3, and 6, over all of our factors of 1, which is 1, could be positive or negative, any of them. And we're just going to test one of them. First one I think I'll test, usually positive 1 over 1 is a good one to test. So let's try f of 1. It's a pretty easy one to test for usually. We're going to have 1 cubed plus 4 times 1 squared plus 1 minus 6. When I simplify, I get 1 plus 4 plus 1 minus 6, which is the same as 6 minus 6, which equals 0. So that's awesome. We found a root. That means x minus 1 is a factor. And that's because of our remainder theorem and the factor theorem. So we know that if f of 1 is 0, then when we divide f of x by x minus 1, we're going to get no remainder. And that's exactly what we have to do now. Now we can use synthetic division because x minus 1 is a binomial that has a 1 here, not a 2 or a 3 or any other number. So let's go ahead and use synthetic division. I'm going to set up my coefficients from f of x, which are 1, 4, 1, and -6. I'm going to draw my synthetic division box here. I'm going to put my root on the outside. Now we know we're going to get a remainder of 0, so we don't have to be worried about that. It's just a matter of what our equation is going to be that we're going to draw from this. So we'll get a 1. 1 times 1 is 1. 4 plus 1 is 5. 5 times 1 is 5. 5 plus 1 is 6. 6 times 1 is 6. -6 plus 6 is 0. We don't so much care about the 0, but we do care about this 6 being our constant. This is going to be our x term. And the next term over is going to be our x squared term. So what we just did is, and I'm going to draw it in blue, we took x cubed plus 4x squared plus x minus 6, and we broke it down. We pulled one factor out, and that was x minus 1. That left us with this quadratic, x squared plus 5x plus 6. Now we have to break that one down. If we can double bubble it, that's great news. If we can't, then we're going to have to use the quadratic formula. Luckily, this thing double bubbles nicely into x plus 3 and x plus 2. Once we've factored this whole thing, all you're going to need to do is identify what the roots are so that you can plot them on this graph. You have the 3 factors, so you'll be able to figure out what the roots are from there. Make sure that you use the correct y-intercept, and make sure that the end behaviors do what they should do for a positive odd root polynomial, or odd degree polynomial rather. All right, guys, good luck, and I'll see you all tomorrow.